Okay, so let's explore Sentieon. So as you can see on your screen, there's a typical genomic data analysis flow. The sequencers like Illumina, PacBio, MGI provide sequencing data, and this comes under the primary analysis. And once we have received this data from our sequencers, we want to understand the observed changes in our DNA, RNA, or the genomic data we were working on. So to do that, we require a secondary analysis software or bioinformatics tools. So based on our primary and secondary analysis results, we annotate these changes to certain conditions or experimental research, as so many options are mentioned over here. And this comes under our tertiary analysis. So in order to reach to this tertiary analysis, we have to use bioinformatics tools or software that are capable of understanding this sequencing data and annotating them with our research objective. To perform this secondary analysis, we do have open source tools, and one of them is GATK, the standardized pipeline for variant calling in somatic and germline datasets. So think of Sentieon as a similarly built pipeline for variant calling that builds upon the algorithms that are used for GATK with certain added features. We know that this secondary analysis part is a time-consuming operation, and the data provided by the sequencer is also large and voluminous. So when the number of samples is small, limited, we can easily deploy these open source tools and perform our analysis. But what happens when we are dealing with huge cohorts, say 100 or thousands of samples at a time? So Sentieon softwares like Sentieon at these time offer verified pipelines to handle the data and execute the secondary analysis rapidly, thus making it a very user-friendly interface. So I'm just going to talk a little history about Sentieon, where it was found, and how the software came into being. So this is a precision medicine focused bioinformatics suite. It was established in 2014 by a research and development team in San Francisco. And this is a secondary analysis tool for NGS data. Sentieon's aim is to deliver secondary DNA and RNA analysis solutions for a multitude of sequencing technologies, including short and long reads from PacBio sequencers. So you can understand that this software is compatible with a variety of sequencing platform and not just one. Now, moving on to our next slide, I'll be comparing the open source bioinformatics tools with Sentieon. So we have open source tools like for alignment, we have BWMM, STAR, and Minimap2. Sentieon offers an upgrade to all these without compromising their efficiency and significant reduction in the turnaround time. Similarly, for germline variant calling, Sentieon offers DNS-seq and DNS-scope. So DNS-seq can be thought of as an upgraded version or equivalent version of GATK, and DNS-scope actually builds and improves the models that were used in DNS-seq. Similarly, with somatic variant calling, TNS-seq, they have TNS-seq and TNS-scope. Apart from that, they also offer BCL to FASTQ conversion, and this process again is accelerated up to 2 times the original speed. Also, they offer RNA variant calling. Similarly, same results. The results are actually equivalent, and the turnaround time is significantly reduced. Now, moving on to the modules that are offered by Sentieon suite. A vast number of modules are offered within this bioinformatics suite. As you can see, the alignment tools, the BAM processing, germline variant calling, somatic variant calling. These I have mentioned already, FASTQ generation and RNA variant calling. Apart from that, Sentieon also offers uh, quality check statistic tools that can be used throughout your pipeline to check the quality of your data and downstream processing. So you can say that Sentieon uses existing GATK best practices guidelines and provides an improvement on the alignment software such as BWMM, STAR, and Minimap2, and variant calling tools such as GATK haplotyper, Mutect, and Mutect2. Now, who should be using Sentieon? So Sentieon is a software that is appropriate for researchers that are working with data from genome sequencing, molecular diagnostics, pharmaceutical, biotech companies, consumer genomics, and cancer research facilities. So it is not like that this software has been extensively tested and confirmed, and they have processed samples comprising over 900 petabases of DNA. One example of this validation is this. So in an independent evaluation of the DNA-seq single sample variant calling pipeline in comparison to that of DNA, this was conducted by Mayo Clinic. And as you can see that we have uh, the speed up, there's a significant reduction in the time it took to complete the pipeline, and the results are equivalent without compromising the actual accuracy of the data or your pipeline. Now, summing up the major pointers from Sentieon, or why you should opt for Sentieon, there's uncompromised precision, there's a significant decrease in the turnaround time, which also leads to cost savings. The analysis is quick. One example is the software is capable of converting 30x WGS data from FASTQ to VCF in under 30 minutes. And the thing is that these softwares can be deployed on any CPU-based machine, generic CPU-based machine. You do not need a system with very high configurations, and thus making this software ideal for cohorts and population-based research. So that is all about Sentieon.